This video is a part of homework 1 for the course Probability and Stochastic Processes under Professor XK Chen at NYU Tanner School of Engineering. So starting off with question 3, the question states that a digital signal 1 or 0 is transmitted through a noisy channel and the received data may be different from the signal that is sent out. We are given that transmitter sends out 0 with the probability 0.6 and 1 with the probability of 0.4, and when 0 is transmitted the receiver receives 0 with the probability of 0.7 and 1 with probability 0.3. When 1 is transmitted the receiver receives 0 with the probability of 0.2 and 1 with the probability of 0.8. So we have two parts. In the first part we need to find the probability that data 0 is received, and for the second part we need to find the probability of error. Now the error is defined as probability that 1 is received when 0 was transmitted, or uh, 0 is received when 1 was transmitted. Now to start off, we'll first define 4 events as follows. So we have 4 events. T0 is 0 is transmitted, T1 is the event that 1 is transmitted, R0 is 0 is received, and R1 is 1 is received. Now let's try to understand this graph in terms of the events that we have just defined. So P of T0, which is probability that 0 is transmitted, is 0.6 as given in the question. P of T1, that is probability that 1 is transmitted, is 0.4. P of R0 given T0, probability of receiving data 0 when 0 is transmitted, is 0.7. P of R0 given T1, probability that data 0 is received when 1 was transmitted, is 0.2. P of R1 given T0, probability of receiving data 1 when 0 was transmitted, is 0.3. And finally probability of receiving data R1 receiving data 1 when 1 was transmitted, is 0.8. Now for the first part we need to find the probability that data 0 is received. So data 0 can be received in two scenarios. The first scenario is we send data 0 and we receive data 0 itself. The second scenario is we send data 1 but we receive data as 0. So we will consider these two scenarios to find out the probability that data 0 is received. Now this can be written as let's first see the first scenario, probability that data 0 is received when 0 is transmitted. So that will be equal to the probability that P of R0 given T0 times P of T0, which means probability of receiving data 0 given data 0 is sent times the probability that data 0 is sent, so which is 0.7 into 0.6. In the second scenario, probability of probability that data 0 is received when 1 was transmitted will be probability of R0 given T1, which is probability that 0 is received given 1 was transmitted, times the probability of T1, which is probability that data 1 is transmitted. So we'll sum these two scenarios up and we get the probability that data 0 is received is 0.5. Now for the second part we need to find probability of error, which is probability that 1 is received when 0 was transmitted, or probability that 0 is received when 1 was transmitted. So again let's see it through the graph. So error occurs when 1 is received when 0 was transmitted, or 0 is received when 1 was transmitted. So for the first case, probability 1 is received when 0 was transmitted. The probability will be P of R1 given T naught times P of T naught, which means probability of R1, that is data 1 is received given 0 was sent, times the probability when actually data 0 was sent. So that is 0.3 times 0.6. In the second scenario, probability that 0 is received when 1 was transmitted, so that will be equal to P of R0 given T1 times probability of T1, which means probability that 0 is received when 1 was transmitted times the probability when actually 1 was transmitted. So that is 0.2 into 0.4. Now summing these two up, we get the probability of error as 0.26.